Now in this problem you can see here there is some trouble over here. Let me make it little up. I hope you can see it, is it not? But still the picture has gone down. So what I will do, I will just read the problem first and then I will move up, because this one, once we read it, you understand it. Here it says at a point in a strained material there is a tensile stress of 80 Newton per millimeter square on vertical plane, fine, and then a compressive stress of 40 Newton per millimeter square on a horizontal plane. So he says compressive, that's done. There is also a shear stress of 48 Newton per millimeter square on each of these planes. The problem looks similar, but see here, he has given you a picture. In the picture, he has shown the value of tau xy in the opposite direction here. It is in the opposite direction here, okay? So again, the same thing he wants. So what I will do, I will just move it up. I will move it up and I will try to make it dark so that you can see it very clearly. Okay, here he say you have a compression, and here he say on the vertical plane it is tension. Okay, this is how much, and then here see the direction is changed. Be careful about this. See there, the direction is changed. In the previous problems the arrows used to be here, is it not? Now where are the arrows? The arrows are at the bottom. Okay, so now what we need to do, we need to put the things in proper perspective. Okay, I have, this is sigma y, this is the mean, this is sigma x, which is minus 40, tau xy is also minus 48. Okay, this is the point, right? So now let us do, once you write this one, it's very easy for you now, because in the science, while writing here, if you make a mistake, you will end up in getting big zero. Okay, now let's try to find out theta 1 and theta 2. The formula is there. Tan of 2 theta is equal to 2 tau xy divided by sigma x minus sigma y. 2 of tau xy is how much? Minus 48. Minus 48 by sigma x. Sigma x is nag is 40. Nag is 80. So this becomes how much? This becomes 2 into 48 is how much? 96, is it not? 2 multiplied by 48 is 96 minus 96 divided by minus 120. This minus sign will go. Okay, divided by 120, that gives me how much? 0.8, but here I am getting positive. Okay, tan 2 theta is equal to plus of 0.8. Therefore, 2 theta is equal to tan inverse of 0.8. So shift off tan inverse of answer. This gives me how much? 38.65. Theta is equal to 38.65 divided by 2. That becomes how much? 19 point something. 19.33 degrees. This is what this is. Theta. This is your theta. Okay. And rather I should call it as what? Theta 1. So in the previous case it was minus. Correct? In the previous case it was minus. Now what happened? Because your tau xy changed, it became how much? It became plus 19 point something. Correct? Now let us just go for what? Let us go for theta 2. Theta, so let me write theta 1. Theta 1 is equal to plus 19.33 degrees. Theta 2 will be how much? 19.33 xi is same. This become 109.33 degrees, correct? So your first plane is where? Your first plane is here. This is 19.33. Xi this in any add. Write a line perpendicular to this line. This will be your theta 2. Okay. Simultaneously you do it. It will be easier. Well, once this is done, what is the next job? Let's try to find out tau max. Tau max square root of sigma x minus sigma y by 2 whole square plus tau x y square. Sigma x is how much? Minus 40 minus of 80. This minus is because of this here, not because of the compression. Divided by 2 zaid tau xy is how much? Minus 40. Put minus 40 inside the bracket. Okay, don't put here minus. So this gives me how much? This gives me 60 square, so 48 square, under the root, okay, under the root, let me write that also, 5904, root of 5904, this gives me, if I make the root of answer, I get it, 76.84 megapascal. This is my tau max. What would be the theta? Theta is equal to theta 1 plus 45 degrees. Just add it. You have theta 1 here, add 45 and write a line here. This is for 45. This is tau max. Okay. You have this. So what is the next job? My next job is to find out what? My next job is to find out sigma 1 and sigma 2. Let me write a tau max also here. Where shall I write? I will write here. Can you see it? I hope you see it. Tau max is equal to 76.84 megapascal. Okay. I have this value. So the next one is what? The next one is let me get rid of this. And I will do it little fast because my camera's battery is dying, so I don't want the recording to stop in between. Let me just finish it off fast. Okay. Now let me do sigma 1, sigma x plus sigma y by 2 plus tau max. So this gives me how much? Sigma x is minus 40 plus 80 divided by 2 plus tau max. Tau max is 76.84. This gives me how much? 18 is 40 is 40 divided by 2 is how much? 20 is 76.84. 76, 86, 96. 96.84 megapascal. This is sigma 1. It is a positive sign, so you have tension here. Just show here like this. Sigma 1. If you want, you can show any different graph also. Okay. So now what is the next value? The next value would be sigma 2 is equal to sigma x plus sigma y by 2 minus tau max. This is how much? You have Ashrin Nagas 76.84. This gives me how much? 56.84 megapascal. This is sigma 2 with your minus sign. You see here, you have a compression here. Okay. Only difference between this problem and the previous problem is because the values remained same, only tau xy changed. So instead of here, it just tilted this side. See the direction in which the stresses have come. Okay. That's it. This is about 3 different cases in compound stresses.